Yes, Nathaniel.
Sir, I think po the difference po if it's concave, yung shape niya po parang kalahati ng circle pero parang paharap. Tas pag convex, parang kalahati ng circle pero patalikod.
Okay. So, yes, Mackenzie. Oh, there, Mackenzie will talk already.
Based out of the shape, concave looks like it's directing away from the light source, so it's like this. And then for the convex, it's like this, which is directly at the light source. Just pretend the light source is coming from the right.
Okay. So, here, no? Okay. Just wait. Before we proceed with the reflective vocabulary, I will just read the one to Denzel. So the reflective coating of the concave mirror is on the outside, and then the reflective coating of the convex is on the inside. Yes. And one of the best example for you to remember the difference between concave and convex, no, is just in the spoon. Okay, isn't it in the spoon like this? Okay, so if this is the one, then that will be the concave. Okay, and then the outside part is the convex. Okay, or the back part of the spoon is the convex. Okay, so that's the one for you to remember. Now let's go to the vocabulary words, no, for you to understand the different things. Here are the reflection vocabulary. Number one, light rays. It is an idealized model of light which is drawn as a straight line. So another is the incident rays. It is an idealized model of light which is drawn as the straight line. So here is the light rays, and the reflected rays is this part. Okay? This is the ray of light which leaves the surface of the mirror. Okay? So, this way. Ay, nako. Okay, ayan. Umuwi na si Jollibee. Sorry, Nathaniel, di na kita malilibre. Umuwi na si Jollibee. Kasi sabi ko, I'll finish my class at 1:40. So, they will come back at 2 o'clock. Okay? So, going back, no, with this one, when we say light rays, no, it is an idealized model of light which is drawn as a straight line. Ay, sayang, deal pa naman sana, sir. Ay, naku, paasa. Pag nagkita talaga tayo, bubugbugin na kita, Nathaniel, paasa ka. Okay? Deal ka na ba, Nathaniel? Okay, deal for Olympic 6. Okay. So, final answer, Nathaniel, ay sayang. Deal na for Olympic 6. Nagtatype na naman. Partner ko po si Francis. All the grade 10, you'll be together. So meaning to say, if you will do an experiment, 6 of you will do that one. Okay? For example, ano bang example? Kunyari, the game before is catching egg. Okay? Example of the concept is projectile motion. So ang gagawin nyo, magpe-play lang kayo ng saluwang itlog. Tapos may given time. So that, ganun lang. Parang ano. Okay? At may concept ng science, projectile motion. Yung mga ganung bagay. Okay? So I'll write your name already, Nathaniel. Sige sir, sali po. Ayun, nako. Diyos ko po, kailangan ko ng budget. Anyway, today's payday. So, kailangan Jollibee. Okay, so Francis and Nathaniel will be exempted in quiz number 2. Okay, yun no, Jollibee. Okay, sige. Parang bigla ko na bigla sa sinabi ko. Bawiin ko na pala, nag-deal na si Nathaniel. Charot. Okay, so remember this is the light rays, no? Okay, usually light rays is a ray because of the object. Okay, while on the other side, the incident ray, it is idealized model of light which is drawn as straight line. Okay, incident ray is an example of the normal a while ago. Later on, I'm going to show that one. Okay, then the reflected ray, It is the ray light which leave the surface of the mirror. So the color blue is what we call the reflected ray. Okay? What about the normal line? The normal line, it is the imaginary line that can be drawn perpendicular to the surface of the mirror at the point of the incidence where the rays strike in the mirror. So this is the normal one. Okay? So let's go on with the angle of incidence. So remember, the color black is the what? What do you call to this color black ray? Wala ka. Uy, grade 10. What do you call to this color black arrow? That is? Yes, John Marlon.
Kita na sa incident.
Okay, what about this one? The color blue.
Normal line po.
Oh, again.
Normal line po.
Color blue, Color blue. Okay, that is the reflected ray. What about this broken line? That is what we call the normal. Okay? Now, what's the difference between angle of incidence versus angle of reflection? So let's try to define this one. Okay? Look at this one, no? Okay? So this is the incident ray. Okay? And this is the reflected ray. Okay? So the angle of incidence is on this part and the angle of reflection is in this part. This is at the back of the mirror already, not actually as in the back. Okay, but you can see that one at the back. Okay? I cannot tell you it. For example, isn't it if you're facing to the mirror, it seems that your reflection is at the back of the mirror itself, isn't it? Okay, so that's the one. So it's written here, angle of incidence is also equal to the angle of reflection. Just like what we talked a while ago, if you're seeing yourself and your height is 164 meters, then in the angle of reflection, your height is also 164 meters. And if your distance is equivalent to 5 meters, if you are in the angle of incident, or incidence, then in the angle of reflection, the distance is also the same as 5 meters. If the angle of incidence is equals to 65 degrees, then the angle of reflection is also the same as 65 degrees. Okay, so that is the one. Okay, so actually this is in your activity. So angle I is the angle between the incident ray and then the normal. Okay, just like this one. This is the incident ray and this is the normal. Then that will be your incidence or angle of incidence. On the other side, the angle of reflection is the angle sub R is the angle between the reflected ray and the normal. So here is the reflected ray and this is the normal. So this part is your angle of reflection. Okay? Question? Okay, now let's go already. So with this part, no? And what about the law of reflection? When we say law of reflection, it is stated that the incident ray, the reflected ray, and the normal line, okay, or normal line to the reflecting surface are all lies on the same plane. So meaning to say, what? This incident ray, this reflected ray, and the normal line are reflecting surface and it is on the same plane. It is here only, okay, on the reflecting surface. Okay, it cannot be the reflected ray is moved from this side. Okay, it should be lies on the same plane itself. But for example, if the mirror is somehow broken, you will notice that a lot of images, no, from that broken part. So that is not an example of law of reflection because that one is different reflected already or different reflected ray you will see. Okay, so next. So the angle of incidence is equal to the angle of reflection. So just like what I told you, whatever the angle here is also the same with the reflection or angle of reflection. Okay? So here's the question. What is the angle of reflection if the angle of incidence is 80 degrees? Again, what is the angle of reflection if the angle of incidence is 80 degrees? Yes, Maynard? Maynard? What is the angle of reflection if the angle of incidence is 80 degrees? Hello, Maynard? There, Maynard is not here anymore. Yes, Carl, Kevin. Maynard?
I don't know po.
What's the answer?
I don't know po.
Hindi ko naintindihan. Louder, please, Maynard. Kevin, what's the answer? If the angle of incidence is 80 degrees, then the angle of reflection is?
80 also.
Okay, 80 degrees. Cannot be 100 degrees, Nathaniel. Isn't it? Going back. Okay, sabi dito. Saan yun? Okay, here, the angle of incidence is equal to the angle of reflection. So meaning to say, whatever the value of the angle of incidence, that is also the value of the what? The angle of reflection. So that is 80 degrees. Okay, so just like this one. If this is the angle of incidence of the 80 degrees, then in the reflection is also 80. Okay. So I got the point of Nathaniel because there are some mirrors that if you are facing, sometimes you're very sexy in that mirror. Did you notice that one? And then if you will use in the other mirror, you're a bit fat. Did you notice that one? Have you noticed that there are some mirror that if you're facing to the mirror, it seems that you're very thin in that part. But if you will use the other mirror, it seems that you're very fat. Okay? So that's the one. Okay. So these are the types of reflection. What are the types of reflection? We have the specular or regular reflection. So when we say specular or regular reflection, the reflection of light rays on a smooth surface such as mirror or a calm body of water. Okay. If it is regular reflection, you will really see a smooth surface of reflection. Meaning to say there will be no scratch or something. While on the other side, or for example, this one, no? The regular reflection, look at the mountain, and then if you will see on the calm body of water, you will notice that the mountain reflected on the calm body of water. Okay? If you will really see us, Sarah is laughing. Okay, so going back, so we have here, no, on the other side, the cat. I know that's her favorite, no. So look at the cat. If the cat is facing to the mirror, then the cat seeing herself or himself already that this is the cat, because cannot be on the other side. It will be dinosaur or what? Lion, no. So still the same. While on the other hand, another types of reflection is what we call the diffuse or irregular reflection. So what do you mean by irregular or diffuse reflection? So it is the reflection of light rays on rough surfaces such as wavy water or the asphalt roadways. Of course, if that one is asphalt roadways, you cannot really see yourself. Okay? Imagine that this is a wavy water, so you cannot really determine the mountains, no? And on the other side, like this, no? If it is regular, look at the incident ray and the reflected ray. It bounces really, no? Or it produces a reflected image. While on the diffuse reflection, this is light on any surface that we can see but does not reflect an image. Okay. For example, to the foil. You know the foil? Aluminum foil. If you're seeing yourself to the foil, what is that one? Is it you cannot determine as in the whole faces. Okay, so that is an example of diffuse reflection. Okay, next. Let's go to the type of image. Okay, so for the type of image, you have the virtual, which is occurs where rays only appear to the diverge, where a virtual image is right side up or upright. While on the other side, the figure. So look at this one. If it is virtual, okay, if you are looking to the mirror, then what you are seeing is what we call the virtual image. Okay, so look at the image. It is upright. Okay, so whatever we are seeing, no, it is not inverted. That is a virtual. So meaning to say, what we're seeing on the mirror is virtual because we cannot touch what is inside the mirror. That's why it's virtual. Okay, so remember, if it is virtual, it's always upright. While on the other side, which is a real image, don't be confused with the definition, huh? A real image is informed when reflected rays converge in front of the mirror. So a real image is inverted or upside down. So meaning to say, if you are looking to that part, the image is inverted. Okay? So for example, with the projector, no? In the projector, actually the image, no, upon analyzing that one, no, or let's do the anatomy of the projector, you will see that the image is inverted. Imagine that this is the object, and then the one that is projecting is this part. That is what we call the real image because the image is inverted. Okay? So, next, image formed by a plane mirror. Okay, so what about this one? Okay, what you can see, of course, is image. So the image formed by a plane mirror is always erect. When we say erect, it's virtual. No? Okay, or when we say erect, it is upright. Virtual, laterally reversed, and has the same size as the object. And that is what we call the law of plane mirror. So meaning to say, distance image, the DI guys, distance image is equivalent to the distance of the object. Okay? And the size of the image, which is the SI, is also the same as the size of the object. Okay? Laterally reverse. Teacher, what do you mean by laterally reverse? Now, imagine that you are my mirror and I'm the object. So for example, you're Sir Alex, no? So if I'm raising my left hand, then the mirror is raising what? Raising? Hoy, then A. Okay. The right hand. Why? Come on. Papatayin ko na naman tong chat box na to. You're not really using your microphone. Okay? If you're using your left hand, the image is raising his right hand. Okay? So, meaning to say, if the object is raising the left hand, the reflection is right hand is raising. No? That's why, let's have the game. Okay? You will follow Sir Alex. You are my mirror and I'll be the object. Whatever am I doing, you have to do that. Okay? Are you ready? Okay, ready? Please turn on your camera. Okay, ready? Those who cannot follow will have an instant quiz already, Okay, ready? Only hands. Don't worry. Hands only. Okay? Ron will have the reporting about the ray diagram. Ready, ha? Bernadette, you're raising your left. I'm raising my right hand. So meaning to say, you have to raise your like this. Ulit, ha? I'm the object, you're the mirror. Okay? So whatever I will do, you have to follow. But your movement will be the same as the one in the mirror. Did you get the point? Okay, let's try another one. Saan ang kamay? Naku, nagkakandali to. Lara, you're wrong. Carl, you're wrong. Left yung itinaas ko. So, ang itataas nyo ay, Diyos ko, kayo ba, pag naku, matakot kayo pag tumingin kayo sa salamin, tinaas nyo yung kaliwa nyo, tapos yung image nyo, tinataas kanan, tumakbo kayo niyan. Diyos ko po. Okay? You get mirror. And then, if you're raising your left hand, ang itinataas ng image is yung kanan. Isn't it? If you're, for example, like this, okay, ang tinataas. That's why I want to discuss this one face-to-face eh. Okay, let's try again ha. Again, you are my reflection. Although hindi tayo magkamukha, pero gayahin yung ginagawa ko. Okay, ready? Oh. Right to ha. Oh. Oh. Why the others are not racing? I'm racing already. Oh, I'm doing this one. What you will do? Para kay mga pusa. Nathaniel, you're wrong. Eric, you're wrong. Mackenzie, you're wrong. Oh, see? Oh, next. Two already. Oh. Tignan natin kung ano mga. Roy, I cannot see you. I'm raising my left. Oh, what's the one that you're raising? You are my reflection. Pawi, you're wrong. I'm raising my left. Kapag tinaas ko ba yung kaliwa ko? Let's have this one ha. Okay, Pawi. If you are my reflection ha. If I'm raising my left hand, what's the one that you will raise? Ha? Naku, tatakbo. Delikado na. Oh, you get some mirror. Now, you raise your hand. If it is left, what is the one raising in the reflection? Oh, ganon. Okay. Oh, again, ha? Always remember, ha? You are my reflection. Okay, ready? Oh, this one. May I see your hand? Nathaniel, wrong. Jody, wrong. Okay, Akira, wrong. Chanel, wrong. Yes, Gian, you're raising your hand. I'm doing this one, not this one. Gian, you're wrong. Okay, next. Oh. Very good. Run cap, ha? It seems that, okay. Next. This one. What's the one that you will follow? On the other side. Mackenzie, you're wrong again. You're my mirror. Eric, you're wrong. Okay, so that's the one. Okay, so it's laterally reversed. When we say laterally reversed, if you raise your left hand, the one in the reflection will raise the right hand. And if I'm raising my right hand, the mirror or the reflection will raise the left hand. Okay, do you get the point? Mamaya practice niya sa salamin. If you're facing to the mirror, try to raise your left, try to raise your right. And then, pagmasdan niyo yung image niyo kung alin yung tinataas. Kasi di ba nakaharap sila sa image? Yan. Sige, makasigi. Okay. So anyway, that's the one. Huh? So don't be confused with that one. Supposed to be, you will have an activity about that one. So remember, the distance of the image and the distance of the object is the same. So for example, if you are facing to the mirror and your distance is 3 meters, then also the distance of the image is like that, 3 meters on the mirror. Okay? So that's in your activity. Next, magnification equation. What is the magnification equation? So magnification equation tells you the change in size or height, okay, of the image relative to the object and image distance from the mirror. With the formula, magnification is equivalent to h sub I, or height of the image over height of the object, which is equivalent to negative distance of the image over distance of the object. So where M is the magnification, HI or DI is the height or distance of the image, HO or DO is the height or distance of the, HO or DO is the height or distance of the object. The typographical, this is object, the HO or DO. Okay, height or distance of the object. So note, the height of the image will be negative if the image is inverted or real image. Okay? So if it is inverted, the object, always remember that the DI will be negative. Okay? Question? None? Okay, can we move already? Okay, next. Okay? So let us have an example. Calculate the magnification of the image formed by a concave mirror if the height of the candle is 6 centimeter and the image height is 4 centimeter. Okay, try to do that one. Calculate the magnification of the image formed by a concave mirror if the height of the candle is 6 centimeter and the height of the image is 4 centimeter. Okay, you can put your answer in the chat box. Okay, anyone? Finish? So I will wait in the chat box, 0.66 according to Nathaniel. What about the others? Tanashi, Tanagi, 0.67. Okay. Sir, can you show the problem again? Okay. I'm not. Okay, here po. Do you still need to put the centimeter? Are you going to put still the centimeter? Huh? Would that be your final answer? Remember, it's written here. Okay, magnification, close and open parenthesis, there will be no unit. So meaning to say, it is only 0.67 or 0.66 Nathaniel, you did not round up. Okay, so that's the one. But anyway, it's correct also. Why? Because what is our HI? What is the HI in the problem? It's written here, the HI is 6 centimeter. And in the height of the image, concave, if the height of the height of the object is 6 centimeter. And the height of the image is 4 centimeter. That's why you got the magnification of 0.67. So that will be the answer. Okay, so look at this one. The image is inverted, so don't forget to put the negative sign in the value of the height of the image. Okay, so remember this one. If the image of the magnification of an image, if the value of the magnification of an image is less than 1, it means that the image is smaller than the object or reduced in size or height. On the other hand, if the value, please wait. If the value of the object or if the value of the magnification of an image is more than 1, it means that the image is larger than the object or enlarged. Then on the other side, if the value of the magnification of an image is equal to 1, it means that the image size or height is same as the object. Now, upon checking your answer, you got 0.67. Then, what is the size of the image? Jello, what is the size of the image?
Sir, can you repeat the question po?
We got 0.67 a while ago, Jello, isn't it? Did you compute? Okay, now, so since we have 0.67 with the magnification, so what is the size of the image? Is it smaller or bigger or the same size? Look at this on the PowerPoint. It is written here, no? The number 1, number 2, and number 3. If it is less than 1, more than 1, or equal, what will happen to the image?
Smaller po.
Smaller. Why do you think smaller?
Because it's less than 1 po.
Okay, very good. Because it's less than 1, that's why the image is smaller. And upon checking on the problem, no, look at the problem. Okay, so it's written here that the height of the object is 6 centimeter. And the height of the image is 4 centimeter. At this point, you can determine already that the reflection or the reflected object is smaller because of the 4 centimeter. You get the point? Okay. Then when you computed, then you really show that the answer is correct. Okay? So that's the end of the session for this afternoon. Okay, I'm planning to add more, but it's already 1:34 and we're up to 1:40.